Welcome back to another chemistry MCQ questions. In each question, I'll be giving you 5 seconds to answer. If the 5 seconds is not enough, you can pause the video, read through the question and answer the question. Number 1. The periodic classification of the element is an arrangement of the elements in the order of the The periodic classification of the elements is an arrangement of the elements in the order of their E. Atomic weights, B. Isotopic weights, C. Molecular weights, D. Atomic number. The correct answer is atomic numbers. So atomic number is also known as the number of protons in an element in an atom, and the modern periodic table is arranged based on the atomic numbers. Now for isotopic number or isotopic mass, it is the mass of a specific isotopes of an element, and it is measured in atomic mass units. Now for example, carbon has some isotopes, like we have carbon 12 and carbon 13, and the isotopic weight of carbon 12 is 12 atomic mass units, and the isotopic weight of carbon 13 is 13.003 atomic mass units. Now for molecular weight is the sum of the atomic weights of all atoms in a molecule. For example, we have water that has 2 atoms. We have hydrogen and oxygen. The atomic weight is the sum of the weight of hydrogen, which is 2, and the weight of oxygen, which is 16, to give us the atomic weight of water. Number 2. If 1 liter of 2.2 m sulfuric acid is poured into a bucket containing 10 liters of water, and the resulting solution mixed thoroughly, the resulting sulfuric acid concentration will be A. 2.2 m, B. 1.1 m, C. 0.22 m, D. 0.11 m. The correct answer is 0.22 m, which is C. When m signifies molarity, which is the concentration of a substance in 1 liter of water. So when you are given a question and there's molarity and volume, then it is wise to use this formula C1V1 equals to C2V2, which is concentration of the first substance times the volume of that first substance equals to concentration of the second substance times the volume of the second substance. And from the question, the C1 is 2.2, concentration of the sulfuric acid, the first volume is 10, is 1 liters, then the second volume is 10 liters. So that they're asking you to find this concentration of the second substance. Now for this, C1V1 equals to C2V2. C1 is 2.2, C2 is V1 is 1 equals to C2, which is unknown, times V2, which is 10 liters. Now for you to get C2, you divide both sides by 10. Divide both sides by 10 to get C2. Therefore, C2 will be 2.2 times 1, which is 2.2 over 10. 2.2 divided by 10 is 0.22. So the concentration of the second solution after mixed with 10 liters of water will be 0.22. Number 3. Look at the diagram. Here is the question. In the above experiment, the litmus paper will initially A. be bleached, B. turn green, C. turn red, D. turn blue. The correct answer is the litmus paper will turn blue. Now, when solid ammonium chloride is heated, it undergoes sublimation, meaning it directly converts into gaseous state without passing through the liquid phase. And the two compound that is formed when we heat ammonium chloride is ammonia and hydrochloric acid. So the effect of this compound on litmus paper is that the ammonia is a basic gas, and it turns red litmus paper blue, while the hydrochloric acid is an acidic gas and it turns blue litmus paper red. If from the slide you can see that I highlighted blue, so you can help you remember that basic compound like ammonia turn red litmus paper blue, and blue is the final product of a basic compound, so it turns red litmus paper blue. The question now will be, which of the following will be the first to appear? Because we have turn red and turn blue, and we know that ammonium chloride contains two compounds, ammonia and hydrochloric acid, that can still give you the same effect. They can turn red and turn blue, but the question here is, what will be the effect initially on the litmus paper? Now from here we should know that ammonia sublimes faster than hydrochloric acid. Ammonia diffuses faster than hydrochloric acid because of the difference in physical properties and chemical properties, one of which is that ammonia has a molecular weight of 17 grams per mole, and hydrochloric acid have a molecular weight of 36.5 grams per mole. This makes ammonia a lighter molecule and it diffuses faster. Another thing you should know is that hydrochloric acid has a higher boiling point than ammonia. So when you heat ammonium chloride, the ammonia will be the first thing to sublimes, followed by hydrochloric acid. Now, I also want you to know that the experiment that was shown is also called fountain experiment. This can be asked in your exam. They'll give you the diagram and ask you what can this experiment be called. So this experiment can also be called a fountain experiment. When ammonium chloride is heated, ammonia reaches the litmus first, turning it blue, before the hydrochloric acid arrives, which now turns it red. So the first thing you should see when you're doing a fountain experiment is the change of litmus paper to blue before it becomes red, because ammonia diffuses faster than hydrochloric acid, which are the two compounds formed when heating ammonium chloride. Number 4, a correct electrochemical series can be obtained from potassium, sodium, calcium, aluminum, magnesium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold by interchanging A, aluminum and magnesium, B, zinc and iron, C, zinc and lead, D, lead and hydrogen. The correct answer is aluminum and magnesium. And from the diagram, we can see a correct electrochemical series. In the correct electrochemical series, we have magnesium before aluminum, not aluminum before magnesium. Okay, here's a mnemonic that can help you know which came first. And with this sentence, you can know how to remember this electrochemical series without stress. And the sentence is, please stop calling me a zebra. I like her calling me my smart girl. Please stop calling me a zebra. I like her calling me my smart girl. You can write this down somewhere because it can help you get 3 points in your exams. The P in please help you to remember potassium. S in stop for sodium. C in calling for calcium. M in me for magnesium. A helps remember aluminium. Z helps remember zinc. I for iron. L and like helps remember lead. H in her helps remember hydrogen. C in calling helps remember copper. M in my helps remember mercury. S in smart helps remember silver, and G in girl helps to remember gold. So with this memory tips, you can remember your electrochemical series. There's other things. There are things I want you to know about the electrochemical series is that The elements above hydrogen in the series are more reactive and can displace hydrogen from acid. If this is hydrogen, the elements above hydrogen are more reactive than hydrogen, so they can displace hydrogen in acid, while the elements below hydrogen are less reactive than hydrogen, so they can't displace hydrogen in acid. So this can also be asked, so you need to take note of this. Playing the mnemonic can help you get 3 points in your exams. Number 5. A basic postulate of kinetic theory of gases is that the molecule of gas move in straight lines between collisions. This implies that a basic postulate of the kinetic theory of gases is that the molecules of a gas move in straight lines between collisions. This implies that A. Collisions are perfectly elastic. B. Forces of repulsion exist. C. Forces of repulsion and attraction are in equilibrium. D. Collisions are inelastic. The correct answer is collisions are perfectly elastic. The kinetic theory of gases is based on the following assumption: that gas molecules are in constant random motion. They move in a straight line until they collide with one another, until they collide with another molecule or the wall of the container. Secondly, that collisions are perfectly elastic, which when gas molecules collide with each other or with the wall of the container, there is no loss of kinetic energy. So collisions are perfectly elastic. Third is that the volume of the initial gas molecule is negligible. The volume of the initial gas molecule is negligible. Now the actual size of the gas molecule is very small compared to the volume of the gas. The actual size of the gas molecules is very small compared to the volume of the gas. Now, there is no intermolecular forces. Gas molecules do not attract or repel each other except during collision. There is no intermolecular forces because gas molecules do not attract or repel each other during collision. The fifth is that the average kinetic energy of gas molecule. The fifth is that the average kinetic energy of gas molecule depends on temperature. The kinetic energy is directly proportional to the absolute temperature. And finally, that the time spent in collision is negligible, as most of the time gas molecule travels freely without collisions. So here's a mnemonic or a memory tip that can help you remember all this that I've just said about the assumption of kinetic theory. And this mnemonic is gas free. G for gas molecule move in random motion. A for all collision are perfectly elastic. S for the size of the molecule is negligible. F for the forces between the molecules are absent, so there's no attraction or repulsion forces. R for this random motion until collision. E, the kinetic energy depends on temperature. And E, the last final E is that the elapsed time in collision is negligible. So for B, the option B says that the force of repulsion exists. So from our assumption of kinetic theory, there is no force of attraction or repulsion because the ideal gas, the intermolecular force are assumed to be negligible except during collision. Now this option C says that force of repulsion and attraction are in equilibrium. This is incorrect because the kinetic theory assumes that gas molecules do not exert significant forces on each other. The option D says that collisions are inelastic. This option is incorrect because inelastic collision would result in a loss of kinetic energy, which contradicts the assumption of kinetic theory, which says that collisions are perfectly elastic because there is no loss of kinetic energy. There is no loss of kinetic energy. Number 6. On which of the following is the solubility of a gaseous substance dependent? I. Nature of the solvent. I. Nature of the solute. I. Temperature. IV. Pressure. E. I. I, and IV. B. I and I only. C. I only. D. I, I, and IV only. The correct answer is I, and IV. Now, the solubility of a gaseous substance in a liquid depend on the following factor: the nature of solvents. Some solvents dissolve gaseous better than others. Example, a polar solvent like water dissolve polar gases like ammonia and carbon dioxide, while a non-polar solvent dissolve non-polar gases like oxygen in water. The nature of solute. Different gases has different solubility. For instance, carbon dioxide is more soluble in water than oxygen due to interaction within the water molecule. The next is the temperature. Increasing temperature usually decrease gas solubility in liquid. This is because gas molecule gain more kinetic energy and escape from the liquid phase more easily. So the temperature can affect the solubility in water. The next is pressure. Gas solubility increase with increasing pressure. Pressure can affect the solubility of a gas. Increasing the pressure of a gas will increase the solubility. In carbonated drink, the pressure within the bottle is increased, making the carbon dioxide dissolved in liquid, making the carbon dioxide dissolve in liquid. And this supports Henry's law, by increasing the pressure of a gas, increase the solubility of that gas. Other things you should know is that the presence of dissolved salts can decrease solubility. Gas solubility is called salting out effect because ions in solution reduce the ability to the ions in solution reduce the ability of gas molecule to remain dissolved. Oxygen is less soluble in salt water than fresh water due to the high salt concentration. Number 7. Which of the following statements is correct about the periodic table? Which of the following statement is correct about the periodic table? A. Elements in the same period has the same number of valence electrons. B. Valence electron of the elements in the same period increase progressively across the period. C. Elements in the same group have the same number of electron shells. D. The non-metallic properties of elements tend to decrease across the period. The correct answer is B. The valence electron of elements in the same period increase progressively across the period. Now, that's the correct answer. Now, for B, as you move across the period from left to right, the number of valence electrons increases progressively. Example, in period 2, lithium has 1 valence electron, beryllium have 2 valence electrons, boron has 3 valence electrons, and carbon have 4 valence electrons. So as you increase across a period, the valence electron across that period increases. Now, for A's element in the same period do not have the same number of valence electrons. So instead, elements in the same period have the same number of shell because the valence electron increases from left to right across the period. Now for C is incorrect because elements in the same group have the same number of valence electrons, but they don't have the same number of electron shell. The same number of electron shell is seen in elements in the same period, not elements in the same group. Elements in the same group have the same number of valence electron, but they don't have the same number of electron shells. Now, D is incorrect because non-metallic properties actually increase across a period, not decrease. The non-metallic properties increase across the period, they do not decrease. So non-metallic properties are found on the right side of the periodic table. So non-metallic property from group 1 to the last group increase across the period, not decrease. Number 8, the boiling of fats and aqueous caustic soda is referred to as A. Hydrolysis, B. Esterification, C. Acidification, D. Saponification. The correct answer is saponification. Now, saponification is a chemical process in which fat and oil react with strong base like sodium hydroxide to produce soap and glycerol. This reaction involves the hydrolysis of ester bonds in the triglyc- triglyceride, resulting in formation of fatty acid, salts, and glycerol. For hydrolysis is involved in saponification. However, it is a more general term that refers to the breaking of bonds with water. While for esterification is the opposite of saponification. It refers to the formation of esters from acid and alcohol. For acidification refers to the process of making a substance more acidic, and this is unrelated to soap formation. Number 9. Which of the following pairs of substance will react further with oxygen to form a higher oxide? Which of the following pairs of substance will react further with oxygen to form a higher oxide? A. Carbon dioxide and water. B. Nitric oxide and water. C. Carbon monoxide and carbon dioxide. D. Sulfur dioxide and nitric oxide. The correct answer is sulfur dioxide and nitric oxide. For A is incorrect because carbon dioxide is already in its highest oxidized form, so it does not react further with oxygen. Also, water is also in its fully oxidized form, so it does not react higher with oxygen. The next, which is nitric oxide can react with oxygen to form nitric dioxide. However, water is in its fully oxidized form, so option B is also wrong. For option C, carbon monoxide can react with oxygen to form carbon dioxide. However, carbon dioxide, which is the second part of the option, is in its oxidized form, so that option is wrong. Now for the correct option, sulfur 6 oxide, sulfur dioxide can react with oxygen to form sulfur dioxide. The second part of the option there is that nitric oxide can also react with oxygen to form nitrogen dioxide. Number 10. In the preparation of oxygen by heating potassium chlorate in the presence of manganese dioxide, only moderate heat is needed because the catalyst acts by in the preparation of oxygen by heating potassium chlorate in the presence of manganese dioxide, only moderate heat is needed because the catalyst acts by A. Lowering the pressure of the reaction, B. Increasing the surface area of the reaction, C. Increasing the rate of the reaction, and D. Lowering the energy barrier of the reaction. The correct answer is D. Lowering the energy barrier of the reaction. Now, manganese dioxide acts as a catalyst in a thermal decomposition of potassium chlorate. A catalyst lowers the activation energy of the reaction, allowing it to proceed at a lower temperature than it would without the catalyst. It does it by providing an alternative reaction pathway with a lower energy requirement. This explains why moderate heat is sufficient for the decomposition of potassium chlorate when manganese dioxide is present. Thank you for watching this MCQ series. If this series was impactful, please like, share, subscribe.